Hi, Steve here from Inverters Lithium again. Just wanted to talk about today, video about the matching up your inverter and your lithium battery. It's important that this combination is correct for the inverter to work correctly. So what's important is to know the size of the cell inside the battery, obviously the output of the BMS, and then also matching it to the input requirement for the inverter. Now this battery here is a 24 volt 50 amp hour battery, green marine battery, and the cell inside here is a 50 amp cell. So what that means is that that cell has a maximum discharge of 1C, which is its capacity, which means it can produce 50 amp. Now this inverter here, I don't know if you can see up here, it's a 4,500 watt inverter. Now just the thing on inverters, when you buy an inverter, often they may label them as 6,000 watts. Sometimes read the specifications, but that may mean that the inverter can put out a maximum of 6,000 watts for a couple of seconds, but then it drops down to 4,000 watts continuous. So the continuous output is what you need to understand. Understanding that if you to put a kettle on, for example, they're normally about 2,000 watts. So you need to have an inverter that can produce 2,000 watts continuously. Other things to understand, that the peak wattage that they often detail in the specifications is to help run things like pumps or air conditioners that need a whole heap of, and fridges for that matter, a whole heap of watts to start the electric motor running, and then when they're running they drop down. So that's why they put the two types. But anyway, so this battery is a 50 amp hour cell. It's got a 100 amp BMS. So this battery here can produce 1,200 watts. So that's the maximum this battery can put out, 1,200 watts. Even though this is a 4,500 watt inverter, it won't produce 4,500 watts because this battery can only produce 1,200 watts. Now, for this battery to produce the 6,000 watts, which is the peak you really want to set it at, it would have to produce 270 amps. Now that means you would need to have at least a 300 amp cell to produce 300 amps out of the battery cell. You'd need to have a 300 amp BMS so that you can produce 6,000 watts of power at its peak. If you just add the continuous 4,500, it would need 190 amps at 24 volt because this is a 24 volt inverter. This is also the same if you want to convert a 12 volt battery into a 36 volt output to run a trolling motor or something, for example. Yes, you can do it, but you need to make sure that the maximum output current required for a trolling motor, and let's use the Kraken for example, the Garmin Kraken, it needs about 61 amps to reach its maximum. Bit of voltage drop, you could probably say 62. So you need to have a 12 volt to 36 volt converter that can at least put out 62 amps. Then again, you also then need to have a 12 volt battery, and if we said 60 amps, the 12 volt battery would have to be 3 times that, so you'd have to have a 12 volt battery that puts out 180 amps continuous at 12 volt. So then if you actually get the right inverter to run the Garmin Kraken, the battery you would probably need is at least a 12 volt 200 amp hour battery with a 200 amp hour BMS maximum output. So hopefully that's been of some help. If you've got an inverter and it doesn't deliver what you say it does, and petrol generators often do the same thing, they have a peak and a continuous rate, check the specifications. Check the specifications on the battery that's running it, and make sure they all align or greater in the battery's case for these sort of appliances to run effectively.